Imagine standing at the edge of a cliff, gazing out into the cosmos where the stars twinkle like diamonds scattered across an infinite blanket of darkness. You feel the weight of the universe pressing down on you, the vastness of it all. But then, what if, in that very moment, something extraordinary happened? What if humanity could suddenly peer deeper into the cosmos than ever before? We could see galaxies as they were billions of years ago, uncover hidden stars and planets, and maybe, just maybe, understand the mysteries of the universe in ways we've never imagined. That's the world we now live in, thanks to the incredible power of the James Webb Space Telescope, JWST. JWST has not just expanded our view of the universe, it has shattered the limits of space exploration itself. Launched in December 2021, this telescope was designed with one singular goal: to revolutionize our understanding of the cosmos. It's not just an upgrade to its predecessor, the Hubble Space Telescope, HST. It's a whole new era in space exploration. Imagine going from a black and white television to a high-definition 4K display. That's the leap we're talking about. And in its first year, JWST has delivered some of the most stunning, jaw-dropping images and discoveries that we could ever hope to see. In just the first year of its mission, JWST has unlocked secrets that were previously hidden behind cosmic dust far away in the infrared spectrum. Where HST saw distant galaxies as faint smudges, JWST has brought those galaxies into vivid focus, revealing their intricate structures, star systems, and even the formation of galaxies from when the universe was just a few 100 million years old. This is the dawn of a new chapter in space exploration, and it's an adventure that's only just beginning. But why does all this matter? Well, think about this. Everything we know about our universe, from the stars in the sky to the molecules in our bodies, is tied to the laws of physics, chemistry, and time. By studying the early universe, the moments after the Big Bang, we're not just looking at distant objects, we're looking at the origins of everything. How did galaxies form? How did the first stars light up the night? How did planets, and possibly even life, emerge from the primordial soup of the early universe? These are questions that not only help us understand the cosmos, but also our place within it. And this brings us to a crucial point. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning its own journey into unraveling the mysteries of the universe. And your support means everything. If you're excited to continue this journey with us, hit that subscribe button. It's free and it helps us grow this community together. We're all part of this adventure, so come along for the ride. Now that we've set the stage, let's dive deeper into what JWST has discovered in its first year. We'll explore how it's helped us look back in time, uncover galaxies from the infancy of the universe, and gain new insights into the birth of stars, secrets that were once unimaginable. The first major discovery that took the scientific world by storm was JWST's ability to peer back to the very beginning of the universe. Galaxies that formed just a few 100 million years after the Big Bang have now been revealed in stunning detail. Imagine staring at a faint dot in the night sky and suddenly realizing that dot is an ancient galaxy, its light having traveled across space for over 13 billion years. That's the kind of journey we're on here. JWST doesn't just observe galaxies, it sees their birth, their evolution, and their role in the grand cosmic story. This ability to look back in time is a game changer. The telescope can detect infrared light, which allows it to peer through cosmic dust that would otherwise obscure distant objects. This means it can capture light from the earliest galaxies, stars, and even planets, objects formed in the universe's infancy. It's like opening a time capsule from billions of years ago and discovering the origins of everything we know. And while JWST is looking back in time, it's also pointing its instruments at the future. As the telescope continues its mission, it will give us a better understanding of how galaxies evolve, how stars die and give birth to new ones, and how our own galaxy, the Milky Way, fits into the bigger cosmic picture. There's so much to learn, and we're only scratching the surface. But before we dive into the specifics of these incredible findings, let's take a moment to reflect on the significance of what we're witnessing. JWST isn't just a telescope. It's a scientific revolution. It's our window into the deepest mysteries of space and time, opening doors we never thought we could walk through. The discoveries it will make in the coming years could reshape our entire understanding of the universe and our place in it. So, what do you think? Are you ready to see what JWST has found in its first year? Well, hold on tight, because we're about to journey across time and space to explore the galaxies, stars, and science that are changing everything we know. Before we jump into the discoveries, though, I want to remind you that this is just the beginning of something extraordinary. If you're as excited about these discoveries as I am, make sure you hit that subscribe button and join the Cosmic Whispers community. The universe is waiting, and we're in this together. Now let's talk about one of the most exciting parts of JWST's first year, the groundbreaking discoveries about the formation of galaxies in the early universe. This isn't just any ordinary find. It's a monumental leap forward in our quest to understand how the universe came to be. Picture this. The universe is young, only a few 100 million years after the Big Bang. The cosmic canvas is mostly dark, a swirling sea of gas and dust, waiting for the first spark of light to ignite. This is the moment we're about to uncover. Through the eyes of the James Webb Space Telescope, we can peer into a time when galaxies were just beginning to form, like newborn stars blinking into existence for the first time. These early galaxies, hidden in the farthest reaches of space, are not just distant objects. They are the cosmic ancestors of everything we see around us today, and JWST is giving us the first glimpse into their birth. Before JWST, our understanding of these ancient galaxies was more like guesswork than real science. Astronomers had theories about what the universe looked like in its infancy, but the picture was blurry at best. The problem? Light from these distant galaxies was stretched and redshifted to such an extent that it became impossible to see with traditional telescopes. This is where JWST comes in. Its infrared vision allows it to see through the dust and detect the faint redshifted light from galaxies that formed just a few 100 million years after the Big Bang. One of the most exciting aspects of JWST's discoveries is how it's allowed us to observe galaxies that are more distant, and therefore older, than any ever seen before. To put this in perspective, some of the galaxies JWST has captured are over 13 billion years old. Their light left these galaxies when the universe was still a baby, just a fraction of its current size. These galaxies are not only ancient, they are the building blocks of the modern universe, the seeds that eventually grew into the clusters of galaxies we see today. But what does it mean to look at these ancient galaxies? It's like peering through a time portal to witness the birth of something truly cosmic. JWST has revealed a staggering detail. Some of these galaxies formed just a few 100 million years after the Big Bang, in a time known as the Cosmic Dawn. This period is when the first stars ignited and matter began to coalesce into the first galaxies. The light from these early galaxies is stretched so far into the infrared that we couldn't see them before JWST was launched. But now the telescope's instruments are unlocking them one by one. For example, JWST has observed a galaxy called JADES GSZ 13-0, a galaxy that existed about 13 billion years ago. This galaxy is incredibly tiny compared to modern galaxies like our own Milky Way, but it holds the secrets to how galaxies first began to form in the early universe. It's a cosmic relic that is helping scientists piece together the story of our universe's origins. This is where things get even more fascinating. Not only is JWST showing us galaxies that formed during the earliest stages of the universe, but it's also revealing how those galaxies evolved. The data suggests that these ancient galaxies weren't just small dim clusters of stars. They were vibrant and active, with star formation happening at an incredibly rapid rate. The stars in these galaxies were burning bright, fueled by the raw materials left over from the Big Bang. The implications of this are profound. When we observe these galaxies, we're not just seeing their physical structure, we're witnessing the very process that formed the universe as we know it. These galaxies hold the answers to some of the most fundamental questions in cosmology. How did matter begin to organize itself into the vast cosmic structures we see today. How did galaxies begin to grow, merging and colliding to form the giant galaxies like our Milky Way? These aren't just questions about distant galaxies, they're questions about the origins of everything, including our own existence. But the discoveries don't end there. One of the most exciting finds from JWST is the detection of what scientists call galactic mergers, when two or more galaxies collide and combine to form a larger galaxy. These events, though rare, are a key part of galaxy evolution. And what's amazing is that JWST has captured images of these mergers happening in real time, giving us a front-row seat to one of the most dramatic processes in the universe. Imagine watching two galaxies collide, their stars and gas clouds interacting in a cosmic dance that lasts millions of years. The merger of these galaxies triggers new bursts of star formation, and the resulting galaxy can grow exponentially. It's like watching the creation of a supergalaxy, the kind that would eventually evolve into massive systems like our own. JWST's ability to capture these mergers is changing our understanding of how galaxies evolve over time. These observations challenge existing theories of galaxy formation, offering new insights into the role that collisions play in the growth of galaxies. The telescope's incredible clarity is allowing us to see the details of these cosmic events in a way we never could before. And with each new discovery, we're piecing together the complex puzzle of galaxy evolution. Now let's take a moment to reflect on the broader implications of all this. When we look at these galaxies, we're not just seeing distant objects in space. We're looking at the very fabric of the universe unfolding. Each galaxy, each star, each merger tells us something about the nature of time and space, the forces that shape the cosmos, and the building blocks of life. By studying these ancient galaxies, we're not just learning about the universe's past, we're unlocking the future. We're discovering how the galaxies we see today came to be, how stars were born, how planets formed, and how life, possibly even life beyond Earth, could have emerged. It's a journey through time, and we're just beginning to scratch the surface of what JWST will reveal in the years to come. The knowledge we're gaining now will help us answer some of the biggest questions in science. For example, what was the first galaxy like? How did it form? What was the process by which the first stars ignited and began to shine? These are questions we've asked for centuries, and now, thanks to JWST, we're finally on the verge of getting answers. The telescope's ability to see back in time, to peer into the infancy of the universe, is like opening a door to a brand new chapter of cosmic history. And yet, for all that we've learned, the biggest discoveries may still be ahead of us. As JWST continues to study galaxies formed billions of years ago, it may unlock even deeper mysteries about the nature of dark matter, the role of black holes, and the forces that shape the very fabric of the universe. Who knows what wonders lie ahead? The birth of galaxies is just the beginning. And as JWST continues to peel back the layers of cosmic history, we'll have a front-row seat to the greatest adventure humanity has ever undertaken. This isn't just a telescope. It's a time machine, a cosmic explorer, and a key to unlocking the deepest secrets of existence itself. Now, are you ready for what comes next? The next phase of our cosmic journey will take us even further into the unknown as we uncover the mysteries of ancient stars, the very first stars to light up the universe. Stay with us as we dive deeper into the heart of the cosmos, discovering the building blocks of stars and the origins of life itself. Close your eyes and imagine the universe before the first star ever burned its light. It's dark, almost oppressively, so silent, cold and void. But hidden in that darkness, something incredible is about to happen. This is the cosmic moment we're on the verge of witnessing, the birth of the first stars. These stars are not just points of light, they are the architects of everything that would come after them, galaxies, planets, and perhaps life itself. With the James Webb Space Telescope's incredible ability to peer into the infrared, we are now able to witness this monumental moment in the history of the universe. In the first few 100 million years after the Big Bang, the universe was a vastly different place. It was made mostly of hydrogen and helium, the simplest elements, light and cold, a vast and empty expanse. But as the universe expanded, it began to cool. These tiny particles, hydrogen atoms in particular, began to clump together, forming the first clouds of gas. The gravitational forces between them grew stronger, and slowly, over millions of years, these clouds began to collapse inward, their density increasing until, at last, a spark was created. This spark wasn't just any spark, it was the birth of the first stars, which astronomers call population 3 stars. These stars were unlike any stars we know today. They were massive, burning with an intensity that was both spectacular and violent, but they were also short-lived, burning out quickly in a blaze of brilliance, their lives ending in massive supernovae. JWST has given us an unprecedented glimpse into this ancient moment. The telescope's infrared capabilities allow it to peer through cosmic dust and see beyond the limits of traditional telescopes. It can detect faint signals from these ancient stars that were born when the universe was only a few 100 million years old. We are seeing the universe as it was in its earliest, most energetic form, a cosmic flash of brilliance in a dark and cold expanse. This is the very dawn of starlight, the beginning of everything that followed. But what makes these first stars so important? To understand their significance, think about this. Stars are the cosmic factories where elements are created. Everything heavier than hydrogen and helium, elements like carbon, oxygen, nitrogen, was forged in the hearts of stars. The first stars, though, were essential because they were the first to produce these elements. Before their birth, the universe had no metals, no solid materials. Life as we know it couldn't exist in that environment. These first stars produced the elements necessary for the formation of planets and eventually life itself. So in a very real sense, the first stars are the forges where the building blocks of life were made. They are the true parents of our universe. In the case of JWST, it's not just about seeing these stars in the distant past. It's about understanding their influence on the universe. The first stars didn't just light up the darkness, they ignited the process of galaxy formation. These massive fiery stars lit the way for other stars and galaxies to form, causing chemical reactions and supernovae that spread heavier elements throughout the universe. The aftermath of their deaths helped to seed the very galaxies we see today. The birth of these stars marked the beginning of a series of events that would lead to the formation of planets, the emergence of life, and the very structure of the universe. JWST has not only observed these early stars in stunning detail, but it's also providing evidence that some of these ancient stars may have been more massive than previously thought. Early studies suggest that these population 3 stars could have been as much as 100 times the mass of our Sun, much larger and more luminous than anything we see in the present-day universe. These colossal stars burned through their fuel incredibly quickly, living only a few million years before dying in explosive supernovae. Yet their legacy is eternal. The heavy elements they released into the cosmos became the building blocks for later generations of stars and planets. Now imagine what happens when one of these stars dies. After a supernova explosion, the outer layers of the star are scattered into space, leaving behind a dense core. This core could collapse into a black hole, a region of space where gravity is so intense that not even light can escape. It is theorized that many of the supermassive black holes we see at the centers of galaxies today may have had their origins in the deaths of these ancient stars. JWST is pushing the boundaries of our knowledge about these processes, helping us understand how black holes began to form and how they influence the galaxies around them. JWST's ability to detect these ancient phenomena is pushing the frontiers of astrophysics. Take, for example, the discovery of the first light echoes. When these first stars exploded, they emitted waves of radiation that traveled across the universe. Some of this radiation has been bouncing around for billions of years, creating ripples that JWST is now able to observe. These light echoes provide scientists with a kind of cosmic fingerprint, a glimpse into the death throes of the first stars. They offer a way to study the processes that led to the formation of black holes, galaxies, and even life itself. Beyond the stars themselves, the death of these ancient stars also played a pivotal role in creating the conditions necessary for life to form. The heavier elements scattered by the supernovae enriched the surrounding gas clouds, providing the raw materials for later generations of stars, planets, and even life. Without these elements, there would be no carbon, no oxygen, no silicon, the very elements that make up everything on Earth. Life, as we know it, wouldn't exist without these cosmic furnaces. These stars didn't just illuminate the universe, they created it. With JWST's groundbreaking observations, we're not just learning about the birth and death of stars. We're learning how the universe itself evolved from a barren, inhospitable place into the rich, complex environment we see today. As we continue to observe these ancient stars and their remnants, we'll uncover the deep connections between stardust, galaxies, and life itself. The telescope is opening a new chapter in the story of life's origins, one that might eventually help us answer some of humanity's most profound questions. How did life begin? Are we alone in the universe? And what other forms of life might exist out there in the stars? The first stars didn't just illuminate the universe, they set the stage for the creation of everything we know, everything we are. And as JWST continues to look deeper into the past, we're getting closer to answering these questions. The cosmic journey has only just begun. As we move forward, we'll explore how these ancient stars gave birth to the first galaxies, and how those galaxies led to the emergence of life on Earth. But before we get there, take a moment to think, what does it mean to truly understand the origins of life itself? What if the secrets to life are written in the stars, and we're finally beginning to read the pages? Stay with us, because what comes next will blow your mind. What if, in the distant reaches of space, there are more planets like Earth, worlds teeming with life, waiting to be discovered? Could the same ingredients that sparked life on our planet exist elsewhere in the cosmos, lying dormant until the right conditions ignite the flame? The James Webb Space Telescope is not only unlocking the secrets of the early universe, but it's also bringing us closer to answering one of humanity's most profound questions. Are we alone in the universe? To understand this question, we need to take a step back, way back, to the origins of life itself. It's not just about stars and galaxies. It's about how the complex molecules that make life possible formed, how they came together, and how the conditions for life were created. And this is where JWST comes in. It is helping us explore the very conditions that could support life beyond our planet. But before we dive into this, let's take a moment to look at the larger picture of what's unfolding. Imagine the universe, 13.8 billion years ago, after the Big Bang. The first stars, massive, fiery giants, burned brightly in the darkness. These stars forged the first elements in their cores. As they exploded in supernovae, they spread these elements, carbon, nitrogen, oxygen, sulfur, throughout the universe. These elements are the building blocks of life, the same elements that make up the molecules in our bodies, the air we breathe, the food we eat. Without these elements, life as we know it wouldn't exist. So in a very real sense, the stars are responsible for life. They are the cosmic forges where the elements that would eventually come together to form living organisms were first created. But these elements alone are not enough to create life. What's needed is a specific set of conditions, stable environments where molecules can form, interact, and evolve. This is where planets like Earth come in. Our planet, situated in a habitable zone where liquid water can exist, is the perfect place for life to flourish. But how many other planets out there might share these ideal conditions? This is where the James Webb Space Telescope is making a monumental difference. With its powerful infrared vision, JWST is able to peer into the atmospheres of exoplanets, planets orbiting stars outside our solar system. The telescope can detect chemical signatures in these atmospheres, allowing scientists to identify the presence of elements like oxygen, methane, and carbon dioxide, key indicators that a planet might be capable of supporting life. In fact, JWST has already begun studying some of the most Earth-like planets discovered so far. For example, It's taken detailed observations of exoplanets in the habitable zone of their stars, where conditions might be just right for liquid water to exist. These planets, located light years away, are the next frontier in our search for life. By analyzing their atmospheres, JWST is helping us understand not only if these planets could harbor life, but what kinds of life they might support. Could there be alien organisms? Perhaps unlike anything we've ever imagined. The possibilities are endless, and JWST is our ticket to the answers. One of the most exciting areas where JWST is making a splash is in the study of biosignatures, the potential signs of life in the atmospheres of distant worlds. For example, the presence of oxygen in a planet's atmosphere could indicate the possibility of photosynthesis, a biological process that plays a central role in life on Earth. Similarly, methane could be a sign of biological activity, as certain microbes on Earth produce methane as a byproduct. If JWST detects these gases on exoplanets, it could be a huge step forward in the search for extraterrestrial life. But detecting these elements is just the beginning. It's about understanding how these molecules interact with their environment, how they cycle through a planet's atmosphere, and how these processes might support life. But there's another frontier JWST is exploring, one that could redefine everything we think we know about life. What if life exists in forms we can't even recognize? Life on Earth is based on carbon, but that doesn't mean life elsewhere must be carbon-based. Could life exist in environments completely alien to us? Perhaps in the oceans of a frozen moon like Europa, or beneath the surface of Mars where water may flow under layers of ice. What if there are entirely new forms of life, built on elements we've never considered? This is one of the most intriguing possibilities that JWST is helping us explore. As it analyzes the atmospheres of distant worlds, we are not only looking for Earth-like biosignatures, we are expanding our definitions of what life might be. Even more exciting, JWST has begun to look at some of the most mysterious objects in space, the moons of giant planets like Jupiter and Saturn. These moons, such as Europa and Enceladus, are prime targets in the search for life. They may harbor subsurface oceans beneath their icy crusts, where life could potentially exist in environments radically different from Earth's. The presence of organic compounds, detected by JWST, could offer the first clues about the chemical processes happening on these moons. These organic molecules could be the precursors to life, or perhaps they are part of a completely different biological process we have yet to understand. Beyond the search for life, JWST is helping us understand the very nature of habitable environments, how planets and moons evolve, how their atmospheres change over time, and what factors contribute to making them livable. Through its observations of exoplanets and moons, the telescope is revealing how the conditions that support life on Earth might emerge in other parts of the universe. This research will help us understand the conditions required for life to take root, whether that's in a sunlit world, with vast oceans, or in the freezing darkness of a frozen moon. And as we look further out into the cosmos, JWST is also revealing the broader patterns of cosmic evolution, how galaxies and stars formed, how the first supermassive black holes took shape, and how the universe itself continues to evolve. The discoveries JWST is making today will pave the way for the next generation of space exploration, inspiring missions that will send humans to other planets, moons, and perhaps even other star systems. The knowledge we gain from studying distant exoplanets, the birth of stars, and the evolution of galaxies is already laying the groundwork for humanity's next great adventure, the search for life beyond Earth. As we stand on the precipice of this incredible journey, the question remains, what are we going to find out there? Will JWST detect biosignatures on a distant exoplanet? Will we discover alien life completely different from anything we can imagine? Or will we learn that Earth is truly unique, a rare gem in an otherwise lifeless universe? Whatever the answer is, one thing is clear. JWST is opening the door to a new era of discovery, one that will redefine our place in the cosmos. The next decade of exploration promises to be nothing short of revolutionary. And the best part we're just getting started. As JWST continues to scan the heavens, we're on the cusp of answering some of the most profound questions humanity has ever asked. Where did we come from? Are we alone in the universe? And what does the future hold for life on Earth and beyond? The answers may be closer than we think. So as we conclude this journey through time and space, remember this: we are standing on the edge of discovery. The universe is vast, mysterious, and full of wonders waiting to be uncovered. Thanks to JWST, humanity is no longer just observing the stars. We're reaching out to them, asking questions, and getting closer to the answers that will shape the future of science and space exploration. What do you think? Will we find life on another world? Or will we learn that we are truly alone in the cosmos? Let's continue this conversation. Share your thoughts in the comments below, like this video, and don't forget to share it with fellow explorers who are just as curious about the universe as you are. The journey is only just beginning. Let's see where it takes us. Thank you for joining me on this incredible journey. What's your next great adventure?